All right, well, welcome everybody to Solar Noon Tuesday. And as per normal, we're going to go through this in kind of three stages. The first part of this event is to go through the news of the week. And then we'll go ahead and talk about upcoming webinars, upcoming events that I've got off of the various emails that come into me. And then we focus in on one topic. Today's topic is going to be focused on why residential solar is still stubbornly expensive. And I think the nice thing about this format is it is interactive. We have folks online, and I do encourage you guys to jump in and ask questions as we do this. So let me jump into the solar news. And this is a recap of the latest solar news, and it's compiled by the American Solar Energy Society. And just to introduce myself, I'm Jay Warmke with solarpvtraining.com. This is the news for the week of March 24th, 2024, in case you're watching this long into the future, time traveling. The solar industry is booming. Solar growth globally has been about 58% from 2022 to 2023, but this growth is not without its problems. The rapid adoption of new technologies, stubborn supply chain disruptions, an inadequate and often undertrained workforce, as well as increasingly severe weather events are all leading to many of these systems underperforming. So we're seeing system underperformance. And a company known as Raptor Maps Global, they had their global solar report, and they analyzed large systems to see just how they are performing compared with what you would anticipate them performing. And they found that equipment faults on these systems have increased from about 1.5% in 2019 to about 4.5% in 2023. So a threefold increase of faults within the systems. And these disruptions have caused a lot of financial harm. In fact, they estimate in this report that losses due to these disruptions are about $4.6 billion annually from lost revenue there. Longi Solar, or actually some of the building of manufacturing facilities, increased competition, again, some changes in policies. All of these have resulted in a number of manufacturers announcing layoffs within their workforce. Longi Solar, who is the largest manufacturer of solar panels worldwide, recently announced they're going to be laying off about 5% of their global workforce, although Bloomberg News reported that that number is going to be closer to about 30%, although Longi denied that, but we'll wait and see. Solar Edge, which is an Israeli-based inverter company, they've seen their market share and stock prices take a major hit in the last 12 months. They've announced that they're going to be laying off about 19% of their workforce worldwide. And Aurora Solar, they're a software company in the solar industry. They've announced they're laying off about 20% of their workforce. Now they're blaming California's recently adopted net metering 3.0 as cause of this. And under NEM 3.0, they basically reduced net metering compensation by about 70% in the state of California. Now that led to about 17,000 people in that state who worked in the solar industry essentially losing their jobs. And Aurora Solar is blaming that as some of their downturn. Senators Peter Welch, a Democrat from Vermont, Angus King, an independent from Maine, and Representatives Kathy Castor, a Democrat from Florida, and Paul Tonko, a Democrat from New York, and Scott Peters, a Democrat from California. They introduced legislation into the House and the Senate called Advancing Grid Enhancing Technologies Act. A bit of a mouthful there. And this is designed to incentivize the upgrading and maximizing of existing infrastructure on the grid, rather than having the utilities focus just on building new systems. Now, the reason why this is important is the incentive program for for utilities under our current regulations is that if they invest in a capital expense, like building a power plant, a solar array, for example, or transmission lines, they get to charge not only what it costs, but a fixed profit margin. So they're incentivized. The more they spend, the more money they make. Maintenance and operations, they can only charge the cost. So really they're incentivized to only invest in new projects. So this bill is designed to incentivize them. I guess you got to bribe them to enhance their current system by putting in technologies such as dynamic line rating, power flow controllers, and save money by making the existing grid, which is pictured here, a lot more efficient. So it's quite a complex there. Now, the savings can be pretty significant. For example, rather than build 2 new transmission lines that would have cost about $50 million, Pennsylvania Power and Light invested only $300,000 in putting controllers and sensors into their existing power lines. And they saw immediate savings of about $20 million a year by avoiding these congestion charges. So that's something that's on the horizon. And there's concern by grid operators that the upcoming eclipse is going to cause all sorts of system disruptions. Basically, those of you on the call know that the grid is essentially a balancing act between supply and demand. Well, they're concerned that areas that are affected by the eclipse are going to see a downturn in solar generation. In fact, they're projecting about 12% decline of solar generation during the eclipse. That would disrupt the models and the algorithms that the balance on the grid is based on. Now, in the 2017 eclipse, they also had these concerns, and they did in fact see a 25% fall off on solar generation during the eclipse on that day. They express concerns that this would disrupt the grid, just as they're doing now. Although it turned out that while production went down, so did demand, because, surprise, surprise, everybody went outside to watch the eclipse. And so electrical demand went down. So I think this is much ado about nothing. And that's the news from the solar industry for this week. So anybody else have anything you'd like? Yeah, Pete, you've got something to add in there?
Yes, the other thing that they failed to anticipate during the 2017 eclipse was as the sun went over, demand for electricity for air conditioning went down. Pretty obvious to those that know astronomy, but they forgot about that on the grid supply side of their worrying.
Mm-hmm. Okay. Yep. I think it really points out, well, something's happening over here. There's something else happening over there. So the world is quite a dynamic system. All right, well, let's jump into the events coming up here in the solar industry. There aren't a lot of new ones this week, but later on today, 2 p.m., there's an IREC session on permitting and inspections. So that's still going on. The 27th at 3:30 p.m., all these times are Eastern, navigating consumer protection issues, and this is done by CEA, Solar Energy Industries Association. There's another one from CEA on Pennsylvania net metering issues. This is 10 a.m. Eastern. The May 20th to 23rd, ASUS will be holding its annual conference at George Washington University in Washington, D.C. So I'll see you guys all there. And June 12th through the 13th, Solar and Storage Summit in San Francisco. And then, of course, we have our ongoing courses and online classes, upcoming in-person classes at solarpvtraining.com. So I will encourage you to jump on board there. And that's pretty much all that came across my desk. Anybody else have anything they want to add to that, or events or webinars that they know are coming up here in the next little bit? Okie doke. Well, let's jump into our topic, and I really am hoping that we'll get a wee bit of a discussion going on here on this one, so don't be shy. The topic that I wanted to bring up, and I think this was recommended to me someone sent me an email saying this would be a good topic, and I agreed. So why are residential solar prices so stubbornly high? So I guess currently residential solar in the United States is in the $3 a watt range. So if you think about the average home, let's say the average home has a 7 kW or a 7,000 watt system, the cost before incentives is going to be somewhere around $21,000. Now, that's not an insignificant investment. So why is that so high? So let's look at what makes up those numbers. So the first thing to think about is hard costs versus soft costs. So the hard costs are going to be essentially the materials, the solar panels, the racking, the wire, the disconnects, all of the things that you would go out and buy. All right, that's only about 45% of the cost of your system. The soft costs more like 55%. So what are these soft costs? How do those things break down? Well, the modules, and most people, when they think about the cost of solar, they're like, yeah, solar module prices are coming down. Well, that's only 12, a little more than 12% of the overall cost. The inverters, about 12%, 11.7 in this particular. I got these numbers from NREL. The structural balance of systems. The structural balance of systems are going to be the racking, the rails. If you're digging a ditch underground, the conduit perhaps. So that's the balance of systems, the structural. That's about 9%, 8.9. Electrical balance of systems. These are going to be your disconnects, fuses, breakers, wire, all of that kind of thing. Those are 12.5% or so. The installation cost, just the labor for installation, is only about 6.5%. And then office work, booming 26%. We'll get into what makes up that number, but that's basically going to be overhead. And miscellaneous charges. We'll dig a little deeper there, but that's another 22%. So really between those two, office, consider that overhead, miscellaneous charges, what's that? 48% of the cost of the system right there between those two things. So let's jump in and look a little bit closer at what we're talking about as far as office work. So office work, the biggest number by far, 3/4 of that is marketing, customer acquisition. You know, going out and finding your next customer. That might be sending people out door to door to knock on doors, which I think is a bad way of marketing, or magazine advertisements, advertising on podcasts, advertising, however you choose to advertise. So a lot of acquisition costs there. Logistics, just coordinating, bringing in the product. Are you going to have it on the site? Who are you dealing with? What, all of the logistical issues. Interconnection, dealing with the utilities. That's going to be about 6.5% of that number. Not 6.5% of the overall cost, but 6.5% of that subsection of the costs. Design, putting together the design, 3%, getting permits, about 6.5%, site assessment, about 3%. So really, if I were just thinking about this, I would have looked at site assessment, design. That's kind of the office work. Well, that ends up only being about 6% of the number. The rest of it is all sort of overhead. Then we get into miscellaneous costs. Yeah, Pete, you had a comment there?
I had a comment. Well, these are very, very interesting numbers, and coming across, there's no way to jot these things down. Is there any way you can make this presentation available to us on a PDF or a PowerPoint presentation format?
Yeah, well, yes. As a matter of fact, these things are always posted on YouTube. So I just encourage you to go into the Blue Rock Station YouTube account, subscribe. You'll get these, but yeah, this will be up there on YouTube, and you can just bring it in looking up Solar Noon Tuesday.
Okay.
All right, Pete.
Yeah, my question is, where is the cost for site assessment on 10 or more sites in order to sell one system? Is that in office work, or is that site assessment? Because I'm thinking there's a considerable expense to these installers on site assessing at so many places to sell one.
Yeah, I think it's under the site assessment number there, and I'll tell you the way that it's normally done is if you get just general interest, you'll do a remote site assessment. I do those all the time, where you just go into Google Earth, you use the software, you do a preliminary assessment, and you can crank one of those out in a half hour or whatever. Then, if somebody's serious, then you're going to go out there on site, but you're really going to have pre-qualified that individual by the time you roll a truck to go out and make sure things are as they appear to be on Google Earth.
Okay.
Any other questions while we're in here for a second? All right. Well, getting into the miscellaneous costs there, profit, I'd hate to pull that number down. In fact, it's a significant part of the miscellaneous, but the miscellaneous, if you recall, if I back up here a couple, miscellaneous is about 22% of the whole cost. So 2/3 of 20%. So there you're talking, let me think, 7-8% profit margin. That doesn't strike me as being exorbitant on the overall cost of the system. Administrative overhead, well, we'll look and find that there are ways to reduce that number. Sales tax, if paying sales tax on the system costs, that's another miscellaneous. And then there's a profit margin to distributors. They got to pay the rent as well. And for the most part, you've got to order through distributors. So I didn't mess too much with that. Having worked for a distributor in years past, I want them to be profitable. So, okay. So that's what makes up the numbers. Okay. That's where we currently are. So then if it's about $3 in the US, well, why is it so cheap in Australia? Here's an example. And the cultures of Australia and the United States, they're different, but they're not that different. So in Australia, the number seems to hang around close to about $1, about $1 a watt for solar in Australia versus about $3 a watt here in the United States. And the average cost of a system here in Australia is going to be just about $6,500, somewhere in that range, $6,500. Now, this does include a $400 per kilowatt incentive. So the incentive program in Australia is a little bit different than the incentive program here in the United States. Comparable in amounts, essentially. In fact, theirs may be a little bit more generous. But what they do is they say, okay, we're gonna give you a government rebate, essentially, or a tax incentive like we have here. But in their case, it's a rebate, $400 per kilowatt. So if you've got a 6,000 watt system, it's going to be $2,400 off the cost. But they don't give that to the consumer. That actually has to be submitted by the installer, and it goes to the installer. The installer will discount the price of the installation by that amount, and it shows up on all of the estimates. So you would get your estimate, it would come in at a certain price. For instance, in this case, let's say $8,000 for your system, less $2,400 for the government incentive. So I'm going to bill you $6,600. That's how that is. Now, the installer, in order to qualify for this incentive, must be certified and registered by the Australian government. So they're saying, all right, you're going to have to go through a certain amount of education, and you're going to have to be certified by the government in order to participate in this incentive program. And you're really not going to be competitive if you're not involved in that incentive program. Here in the US, our incentive program is typically 30% tax credit. So you get into who qualifies, how they qualify, when you get the money, how you get the money. Over there, you get the money essentially as soon as you sign the contract. It's just a discounted off the cost of the contract. Here, you've got to file your taxes. And if you don't owe that much in taxes this year, then it's going to roll over into years in the future. And eventually you'll get the money, but it's just not as clean, not as simple. And there's no kind of stick there to require that the installers be qualified. Now, I don't want to paint a picture that Australia is, nothing but wonderfully qualified installers, because I did run across a number of videos talking about quality issues and concern issues with some of the installation, and people come in and it's, they get shoddy practices like everywhere else. Another thing that's affecting us here in the United States that is not an issue in Australia is tariffs. We have imported tariffs, or tariffs on panels that are imported from China, and they're 25% of the cost of the panels. Now that's 25% of 12.6%, which is the panel's portion of the overall cost. So it adds about 3%, a little more than 3% to the total cost of the project. But it's a cost. It's a cost factor, and Australia doesn't deal with that cost factor. Right? So then we start getting into the real money, where the differences can be had. One interesting thing, which hadn't occurred to me before I really started looking at that, there was a lot of discussion there about how the National Electrical Code adds tremendous layers of unnecessary cost to the installation of solar here in the United States. And these are not in place in Australia. And a few examples, that I can even point to when I'm teaching on solar, they're requiring a separate disconnect to be out there next to the meter, an AC disconnect. And the students are all the time asking me, why is this thing necessary? If the inverter is going to shut down as soon as it loses sight of the grid, as soon as you disconnect from the grid, the inverter shuts down. Why do you need a second system to turn off the solar array? Well, my pat response is typically, well, maybe they don't want to turn off the grid. Maybe they just want to, just turn off the system. Well, all right, fine. But the NEC is mandating that. Another thing that I could never get really good answers on is DC wiring within the home has to be in metal conduit. AC wiring doesn't have to be in metal conduit. It can be in PVC or liquid tight or whatever. Well, metal conduit is typically more expensive and more difficult to install. You've got bending, you've got issues, you've got all this other infrastructure that is just not there with PVC. So added cost there. Why must DC wire be in metal conduit? Not 100% sure. They're talking about arcing and things of that nature. But once again, it was pointed out in the research I ran into that Australia has as good a safety record as the United States when it comes to solar. So we could argue that these things make our system safer, but that's not really bearing out in real world situations. So each one of these things you put in there adds to the cost of the system, and that's going to add to the cost. That's just all there is to it. The NEC really doesn't care about costs. It says we will come up with these things because of safety. We don't care the cost. Another good example is they've just passed this thing about batteries. And batteries cannot be stored inside, and they've got to be outside an X number of feet from this door and that window and all of that. Well, that's going to add a significant cost. The argument there is because lithium-ion batteries are subject to thermal runaway. Well, you say, all right, how many of them have actually had this problem? Turns out a handful. So you're going to change the national code for 5 instances, of these things happening, and the technology is changing, and not all lithium-ion batteries are made alike. Some are more susceptible, some are not. So is that money well spent? I guess, that's a question, but that was definitely one that was raised there. So the NEC definitely, they estimate adds about 49 cents a watt in these. Well, that's a significant amount of money, 49 cents a watt, when you're talking about $3 a watt for the total installation. And time is money, right? The more time you put into this process, the more it costs in overhead, in inspections, in each of these. So I found this interesting graphic. This is from GTM, which is a Wood Mackenzie document. And this just shows the difference in the process. Essentially, in Australia, if you talk to a customer and they want to buy solar, they go online and they fill out an application form that takes about 5 minutes. It's a national standard application. No permitting is required for these systems on homes, unless your house is a heritage or basically a historical site, at which point there are other issues you've got to deal with. The application itself is free, and within 24 hours, you're granted. Your interconnection is essentially granted. In the US, there's a lot of steps. So you schedule that site visit, you run out there, you take you measure everything. Then you've got to create a one-line drawing. You've got to create a site plan. You've got to submit that to the utility. You've got to submit it to the permitting office. You might have to have a permit person come out and look at it. You might have a utility come out. The utility will often require photographs and equipment and listings, and then you come back and then somebody's upset with you, and then you've got to do it again, and you go back and you go back and forth, and so on and so forth. And then you get to install the system after everybody has agreed that you're allowed to install this system. Then you interconnect it, and then you got to wait like 2 months before you can turn the bloody thing on. So right there, you're talking about huge amounts of time. In fact, I've got a number here somewhere. It's like in Australia, it takes 7 to 10 days from I would like to have solar to my solar system is up and running. Here in the United States, you're talking 2 to 6 months for the same process. Well, that's silly. That's unnecessary. It's been proven that it is unnecessary by Australia. They're a good test case for us. And as a result, Australia has about 38% market penetration of rooftop solar. So basically 38% of the homes in Australia have solar on the roof. Here in the United States, it's significantly less than that. I think I saw a number of 6%. I saw a number of 2%, so it's somewhere in that range, I imagine. But it's a lot less than 38%. So they're doing something right that we are not. So how long does it take for solar to be installed here in the US? And I found this graphic that was interesting. Pick the installer, get your site assessment, get a design in place, then you begin to apply. You got to have your design before you can submit for your permits, for your talking to the utilities. Then you begin to order the equipment. It's going to take a while for it to get there. The installation's usually the quickest of the whole process. It's like 1 day, 2 days, somewhere in there for a small residential system. Then you got to schedule an inspection by the inspector, and typically you got to have the installer there while the inspector shows up, and then you got to go through all of this nonsense with the utility. And the utility, when I'm talking nonsense, I mean it really is nonsense. It appears to be designed to slow down the project. I remember with the one here in our office, they made me reapply like 6 times because on one form I had put J Warmke, and on another form I had put Jerome Warmke, or I put Jerome in parentheses J, and they're like, no, that's not the same name. You've got to resubmit this thing, and then we get to start all over. So anyway, so they were annoying. Sales tax. Well, let me take a breath here. Anybody have any comments so far as we're jumping out here?
Well, let me say this, that here in my neck of the woods, the permitting process requires that you get a structural engineer to certify that the roof will handle the load, which the structural engineers that I have contacted want $600 just for that.
Yeah, that I've seen that as well, which is another reason why ground mounted systems, if there's room, are kind of a nice issue. I know in the city of Columbus, we did a thing where they basically require that a licensed electrician pull the permit. So, you know, we had to pay an electrician basically $400 to walk the application into the office and hand it to them. So that's another bit of money that is kind of unnecessary. Now, Australia basically says, listen, we're going to require that the installers be trained and certified. So the permitting issue is kind of a non-issue as far as we're concerned. Do it, don't do it. They know as much or more than the inspection people. Most of the permitting officers who come out and look at solar don't know anything about solar anyway. They may know about grounding and bonding, and they may be looking at that. But for the most part, it's not a significant amount of value add, to the process. Did anybody, I thought I saw someone, yeah.
Jay, just to let you know, in Trinidad is no different. We had the same process permitting and all the process to go through the inspection. So even down here, it's the same thing we deal with.
Yeah. How much is, do you know the residential? I know you do bigger systems, but what is the price per watt down there in Trinidad?
Jay, we don't really have a formalized structure in Trinidad. We say what dollar per watt because a lot of the PV modules come from China. We sometimes pay 19 cents per watt for module, right? And that we have a lot more freedom in terms of the products we can use. It just once it meet these standards, utility might ask either UL or IEC standards. But if I buy an inverter, let's say DEYE from China, string inverter, it costs far less sometimes than what they buy it from, if I buy it, what I buy it actually in the United States. Because when we contact the suppliers in the States, they tell us they have to pay import tariffs on their products, and it costs substantially more sometimes. So we never really got around to that. It is a discussion we have with local contractors, trying to put a figure per watt. But I think it's because we have such a wide variation of products. It's sometimes more challenging to say, a 5 kilowatt system costs this. And then we have off-grid, which is very popular, as well as grid-tie systems, which we're trying to bring on street level.
Did you say that the price you're paying is about 19 cents a watt for solar panels?
Jay, I work at a local company, a distributor company with Longi, which I mentioned earlier today. And they offered us 580 watt PV modules for about 19 cents per watt.
Oh my. Yeah,
Yep.
580. Well, that's not really going to be rooftop solar type thing, though. That's going to be more, utility scale, larger systems, 580 watt panels. So let's all move to Trinidad. There's cheaper solar in Trinidad, and I suspect we can all sit at the beach. We're all going to stay with you, Devanand. So that's good. Everybody's all right. So let me hit the sales tax thing, and again, I'll invite you guys to jump in. But sales tax here in the United States is weird, like a lot of things, where it's a state by state kind of situation. And so I just did a little bit of research here. There are a number of states where there simply is no state sales tax. Those are going to be Alaska, Delaware, Montana, New Hampshire, and Oregon. So it's not an issue. And a number of the states have exempted solar from state sales tax. So I listed those there. I'm not going to read them all off. I'll let you guys sort of look at them to find what if your state's in there. And then the vast majority do tax. So there is sales tax on solar if you're installing it on your home. So I'm assuming, because living here in Ohio, we've never added sales tax to the cost because it's exempt. But I assume when you get a bill from an installer, there's going to be the cost plus sales tax. So then we get into customer acquisition, and the customer acquisition is very high, extremely high. They're saying typically that in the US, for every customer, it costs about $2,500 to acquire that customer. Whereas in Australia, it costs about $400. And this seems to be one of those kind of feedback loop kind of things. It's not that advertising is cheaper in Australia. It's basically that if you're only charging $1 a watt for solar, it's not hard to sell it. It's if you go to somebody, I mean, just imagine if somebody came to you, if you don't have solar on your home, and said, hey, for $5,000, I can outfit your house with solar. That's all it's going to cost. And you can have it in a week, 10 days, whatever. That's a lot easier sale than saying, okay, for $25,000, I'll put solar on your house, and then we're going to go back and forth with paperwork for the next 6 months. And at some point, you're going to get fed up and say, you know what, this just isn't worth it. Forget it. So a lot of customers just disappear from the initial sale to actually getting all of the approvals in place. So the cheaper you make it, the easier it is to sell, and the cheaper it becomes to install, because the sales are just not difficult, not difficult at all. In fact, one person who installs it's going to sell 50 systems for you, because they're going to say, hey, this thing paid for itself in 2 years, and life is great, and everything's wonderful, and so on and so forth. So where are these? So this is sort of the lessons learned here, as far as how do we get the price $3 a watt down to around $1.15, which is in the neighborhood of where it is in Australia. In fact, I'll back up to this slide and I'll just show you the costs here. Where are these costs? Well, the hard costs, the cost of the solar panels, about 34 cents a watt here in the US. If you're in Trinidad, it's only 19 cents, I guess. Australia, it's going to be about 26 cents. And that in large part is because of tariffs, tariffs. And then other hardware. Well, the other hardware costs are going to be more expensive in large measure because the NEC requires you to buy certain equipment that in Australia, for example, they don't have to put in. You don't have the extra disconnect. You don't have the metal conduits. You don't have a lot of things. And this is for grid-tied systems without batteries. If you're putting in batteries, it's all going to be a bit more expensive, a lot more expensive, typically. Then you get into soft costs. Well, in the US, on average per watt, talking about 55 cents versus 8 cents in Australia. The permitting costs around 24 cents here in the US versus 1 cent in Australia. The entire permitting cost is basically free in Australia. The only reason they even put in something is sometimes people will go ahead and pay somebody to do the 5-minute application thing. So installation labor, well, a little bit cheaper in Australia only because it takes less time, because you're not putting in all the equipment, not all of the bits. Other soft costs, well, this is overhead and taxes and things like that, significantly less. And then profit and overhead is 48 cents versus 19. So we're seeing $2.95 in the US versus about $1.25 pre-incentives in Australia. So how do we get the US number down to the Australian number? Is this something realistic that we could do here in the United States? So what an easy one would be eliminating sales tax. That would be something that you could do in the states where it's not currently the fact. So you could be getting 5, 6, 7% savings just by eliminating sales tax. You could remove some of those expensive NEC requirements. Good luck with that, but that's something that could happen. Many of the, even another example is in the US, we're limited to 600 volts for residential systems versus 1,000 volts or 1,500 volts in Europe. It is not inherently safer to have it at that lower voltage, but it does add significantly to the cost of your system because you have to put in bigger wire. Your strings are smaller, so you have more of them and more disconnects and more connection points, things like that. It all adds to the cost of the system. Why does the NEC require that you cannot exceed 600 volts for residential? Because they do. That's it. No one knows, but nobody's changed it. I'm sure somebody thinks they know, but it's probably, we do things. Why do we do things the way we do them? It's because that's the way we do them. So reducing the permitting time overhead that's associated with that time, that would save about 16%. So if we could get rid of all of these redundant permits, there's a little bit of a movement. Solar App Plus is one example where you can go online and use this permitting process, and it's required, or it's being adopted by certain cities. It's baby steps towards that. I suspect it's not going to be a thing until somebody mandates it. I mean, it's slowly happening in some cities, but it's really not nationwide, for example, as it is in Australia. And we could easily adopt the Australian model by saying, listen, if you want to be part of the Solar App application, you've got to be certified and you've got to be trained and you've got to be registered as an installer to be part of that Solar App, to be in that package. And then before you know it, you begin to mandate Solar App in jurisdictions. Reducing the permitting costs right there would be an example. If Solar App is adopted and it's free and all of that to the customer, you've reduced the cost there. And then of course, lower prices end up less marketing. So the cheaper it is, the easier it is to sell, the less you have to advertise it. People are going to seek you out. So that becomes just a feedback loop there. So that just those items there have reduced the cost by 62%, which takes us from the $3 a watt down to about $1.14 a watt. Just by implementing those without dealing with tariffs, without dealing with the fact that you can get solar panels a lot cheaper in Trinidad. So in fact, it's worth a trip down there just to pick them up and bring them back through Miami. I'm sure no one would in your carry-on baggage. So, all right. So that is my recap. Anybody have any comments or disagreements on that? Yeah.
Now I have this is Jim Greckney. I have we have a house in Hawaii, and we put 18 solar panels on 6 years ago, and this year we're putting 6 more on with a battery. And one cost reducer that you haven't mentioned is if states would do like Hawaii does and also offer an incentive to go with the federal 30%. In Hawaii, it's about 20%. So when you put those together, it's 50%, so it's half the cost, and it makes it much more, attractive to go with that.
Yeah, and Hawaii has another incentive of having amazingly expensive electricity, so that definitely motivates you as well, right?
Absolutely, most expensive electricity in the country, something like 32 cents per kilowatt hour, I think, for electricity, and it's variable depending on the time of the day. So yeah, it works out. I'd say between 30 and 40% of the houses, that's my guess when I drive around, have solar panels.
Yeah, that's why it surprised me that Hawaii doesn't, exempt them from sales tax. Because it seems like if you're going to incentivize them over here and then penalize them over there, it's that kind of dysfunctional, schizophrenia that government often has.
Yeah, and I see a lot more of those requirements too on equipment. Like I asked them why they needed a sub panel for an extra $400. It has to do with the battery installation. I don't quite understand it fully, but they said that the electric company required that for safety somehow. I'm not sure, but things like that add the cost up too.
Yep. All right. Anybody else have any comments here or questions before we jump off? Give you guys. Yeah.
Jay?
Uh-huh.
Yeah, there's a couple of things in New York. One is the utilities have territories. We have 5 very big utilities, the Con Ed, NYPA, Rochester, goes on. You're not allowed to cross those lines. Those territories don't allow your solar to go out on electrons, use the line to come around to the dairy barn. Also, they're monopolies. They were granted 100 years ago, let's say. And they have stockholders, and those stockholders are to be kept whole.
Mhm.
So we have a territory thing, summer camps and dairy barns and all that fall into that problem. So in the acquisition costs, it goes up and up and up.
Mm-hmm. Yeah, I think you bring up a good point, and I tried to find out why the utilities in Australia are not causing all of the shenanigans around solar that they're causing here in the US. And I thought maybe their solar grid was nationalized, that it was government owned, but it's not. It's a similar system as we see here. And I think it must just be that the government has said this is what's going to happen. So maybe their regulatory process is not done by people who are wanting to get a job at the utility, after their stint at the Public Utilities Commission is over.
But Jay, I met people from Australia about 10 years ago, and they were just so fussy about solar. And then it turns out, of course, they're stockholders, and the biggest thing that they ship out of Australia, mainly to China, is coal. So you would think that what you're saying is true, that, gee, they're big, huge utilities as national, and one of their main sources of income for the whole country is coal.
Yeah.
And these folks were just like, no, but now look, 35% of Australia, did you say 35% of Australia?
38% of the homes have, yeah.
And it's an amazing turnaround. This guy was so stubborn, but we talked for about a week on a small snorkeling trip. Never mind.
Yeah. Well, I think the US's biggest export is hypocrisy. So
there you go. All right. That's close.
Yep. Hey, Pete, you had a question here or a comment?
Yes, in Wisconsin, there's a patchwork quilt of net metering laws, sort of like apparently in New York. In Minnesota, however, if you sell electricity at retail, thou shalt allow net metering at retail. It's blanket across the whole state, and it really tidies things up over there compared to Wisconsin, where I live.
Yep. Yeah, I think we're bringing up maybe a foreshadow of another discussion I would like to have at a later date, which is when you talk about the patchwork of utilities and the motivations of utilities and things like that, I'm kind of getting more and more of the mind that that we might be heading towards a time when nationalization of the utility grid is going to be a serious discussion. I suspect we're going to see some major failings on the grid, and we've seen the grid has been largely mismanaged. And at some point, the government is spending huge amounts of money on transmission lines, on infrastructure that, I mean, either you own it or you don't, it's like, and if you're not going to manage it properly and you're not going to pay for the upkeep, maybe dad and mom have to come in and take it away. If you won't feed the pet, you don't get to own a puppy. So anyway, that's a discussion for another day. Yeah, somebody mentioning ERCOT down in Texas. Yeah, good example of wonderful management. Well, let's call this discussion here this week at an end, and we'll see you guys all next week. All right, take care.